Hello everyone. In this video, we will be solving yet another problem using Leibniz theorem. And our problem is, if y equals to x square minus 1 to the power n, we have to show that this expression here equals to 0. This expression here equals to 0. So let's move on with the solution. We are given y equals to x square minus 1 to the power n. If you notice, we have 2 here. This means that we have to differentiate y with respect to x 2 times. So let us first differentiate y 1 times with respect to x. Differentiating this equation 1 with respect to x. The derivative of y will be y1 equals to, and the derivative of this term will be n x square minus 1 to the power n minus 1 times 2x, or y1 equals to n. Here we can use the laws of indices. X square minus 1 to the power n times x square minus 1 to the power minus 1, or y1 equals to n x square minus 1 to the power n over x square minus 1 times 2x. If you multiply both sides with x square minus 1, we will get x square minus 1 y1 equals to n x square minus 1 to the power n and 2x, or x square minus 1 y1 equals to 2nx, and x square minus 1 to the power n is y, so we can replace it with y. Now again differentiate with respect to x to get y2. Here we have to use product rule. Now keep x square minus 1 as it is, then the derivative of y1 will be y2, plus keep y1 as it is, and the derivative of x square minus 1 will be 2x, equals to 2n is constant. Now differentiate xy with respect to x. Keep x as it is, and the derivative of y will be y1, plus keep y as it is, and the derivative of x will be 1, so we can just write y, or x square minus 1 y2 plus 2x y1 equals to, now distribute 2n to the bracket, 2n y plus 2n x y1. Now after this step, we are ready to use the Leibniz theorem. Using Leibniz theorem, the step is as follows. First write, since we have 2 here, first write y n plus 2, keeping x square minus 1 as it is, plus write n c1. We have n plus 2 here, so decrement n plus 2 by 1. We will get y n plus 1, and the derivative of x square minus 1 will be 2x, plus now write nc2. Decrement n plus 1 by 1, we will get yn, and the derivative of 2x will be 2. So after reaching to yn, we have to stop for this term and write plus and proceed for this second term. Write 2. Now similar to previous step, since we have y1 here, write yn plus 1, keeping x as it is, plus write nc1. Decrement n plus 1 by 1, we will get yn, and the derivative of x is 1, so we don't have to write 1, plus or equals to, we have 2ny, and the derivative of y is just yn, so 2n yn plus 2n. Now again, similar to this step here, write y n+1, keeping x as it is, plus write nc1 and decrement n+1 by 1. We will get yn, and the derivative of x will be 1, so we don't have to write 1 here. Or x square minus 1 y n+2 plus nc1 is just n, so we can write it as y 2n x y n+1 plus nc2 is n minus 1 over 2. Since this 2 and this 2 will cancel, we don't have to write this. We can just write n times n minus 1 times yn plus distribute 2 inside the bracket. We will get 2x y n+1 plus 2 n yn equals to, we have 2n yn here, plus now again distribute 2n inside the bracket. We will get 2nx y n+1 plus, since nc1 is n, when multiplied with this n we will get n square and yn. Now we can cancel 2n yn and 2n yn, and we can also cancel 2nx yn+1 and this. So we are left with x square minus 1 y n+2 plus, open this bracket, we will get n square yn minus n yn plus 2x y n+1 equals to 2n square yn, or x square minus 1 y n+2 plus n square yn. Bring this 2n square yn to this side, we will get minus 2n square yn minus n yn plus 2x y n+1 equals to 0. We have already got our first term here, so we can write x square minus 1 y n+2. Now arrange the terms with y n+1. We only have this term, so we can write plus 2x y n+1. Now n square yn minus 2n square yn is just minus n square yn, and we have minus n yn here equals to 0. Or x square minus 1 y n+2 plus 2x y n+1. Now take minus ny common from here, yn common from here, we will get n+1 yn equals to 0, which completes our proof. Thank you.